Okay, I'm going to do 7.2 in two parts. Part 1 will be the disk method. In this case, we're going to do a volume given a function and is rotating. Okay. In this case, if we have the function and it's rotating about the x-axis, like in this case, we have the arrow rotating this way, we're going to do it in terms of x. If it's rotating about the y-axis or in that direction, it's going to be in terms of y. So it's going to be a dy. I'm going to do both examples. I'm going to do an example of each so you guys know what to do on each example. So my first example, example number 1. Find the volume of a solid form by revolving the region about the graph f of x equals square root of sine of x and the x-axis. And they give me the boundaries from 0 to pi. Here they also give me the picture. We are always going to get the picture. In this case, we do have a picture. So this is what we have. This is what we have right now. Okay. This is 0 and this is pi, and it's rotating this way. It's rotating along the x-axis. Okay. So the radius is determined by the function. It increases and decreases following the function. So that's the radius. Okay. I think they use a capital L, capital R. So that's the radius. So what are we going to do as our integral? The integral, the volume is going to be equal to pi from A to B. The radius, the function, square dx. That's given to us. That's what we're going to need to do. So from this case, let's set it up. Pi is always going to be a pi. So in this case, our boundaries are from 0 to pi. The function is the square root of sine of x, but then this, I need to square it dx. So we need to square it, so it's going to be dx. Evaluate, let's simplify. So square root and square cancel. So from 0 to pi, I have the square root of sine of x dx. Square root of sine is negative cosine. So I have negative cosine of x evaluated from 0 to pi. So I'm going to have pi up here. And then I'm going to have negative cosine of pi minus negative cosine of 0. Negative and negative, double negatives becomes a positive. Cosine of pi will give me negative 1. But the negative and the negative becomes a positive 1. Plus cosine of 0 is 1. Again, that becomes a positive 1. So 1 plus 1 is 2. The answer will be 2 pi. The final answer is 2 pi. My next example, they only give me the functions that I need to do the rotation with, but they don't give me the boundaries, okay? Look at this one, example 2. Example 2 says find the volume of a solid form by revolving the region by the graph f of x equal to 2 minus x squared and g of x is equal to 1. So I want to find the region where these two, we have these two functions, and I need to know where they intersect to know where I'm doing the rotation. Also, it says that we're doing the rotation about the line y equals 1. First of all, let's see how it looks. Again, if you don't have a graphing calculator, you guys can go to decimals and do it. So here I already did it. I already have my two functions written. You can zoom in, you can zoom out, we can move it a little bit. So this is the area that I'm going to be doing the region, or that I need to find the volume of. Okay, so this is the line g of x equals 1. Okay. So I'm going to show you my graph. I'm going to do a sketch of the graph so you guys can see what we need to do. So we have f of x. A little bit, sorry. So we have here, this is f of x, this is g of x. The area that I want to do the revolution is going to be this area right here with my pencil. And I want to revolve it around this right here. It is still this way. It is still in terms of f of x. It is still in terms of f of x. I want to find the radius. I want to find what the radius is and how is it changing. The radius will be this right here. That's the radius of my sphere that I'm rotating. So in this case, boundaries, where do they intersect? This point and that point. Since we're rotating this way, I just need to find the x values where they intersect. So in this case, x value where they intersect will be -1 and 1. -1 and 1. So then here, I'm going to set up my integral. My integral will be, remember, don't forget the pi in the front, and it's going to be from -1 all the way to +1. And what we're going to do is this radius right here. Okay. Well, in this case, we have the bigger radius. Okay, what do I mean by that? We have this right here. If I only write the function f of x as my radius, it's going to be all of that. I don't want all of that, okay? I just want this little piece right here. So what we're going to do the function f of x minus this right here, which is constant, it's g of x. So to put it more so that you can see more generally, we're going to do from a to b, and I'm going to do the function on the top minus the function on the bottom, and then square it. That's what we're doing. So in my case, we're going to have f of x, which is 2 minus x, minus g of x, which is just 1. And then we square it. Okay? Then we square it. So first, let's simplify. So first, we simplify. So how do we simplify? Well, 2 minus 1 will give me 1. We have from -1 to 1, and I have 1 minus x squared, x. Okay? So, to do this integral, we're going to have to do some algebra first. We're going to have to distribute 1 minus x squared, 1 minus x squared. So first, we need to simplify. So remember, we need to distribute. I'm going to distribute the 1, and then I'm going to distribute the x squared. So I have my pi, -1 to 1. 1 times 1 is 1. 1 times negative x squared. Negative x squared times 1, negative x squared. Negative x squared times negative x squared. Positive x to the 4th. Okay? Let's simplify. Let's combine like terms. To combine like terms, we need to, there's only one constant. Minus 2x squared plus x to the 4th dx. What we're going to do now, we're going to do the integral. We're going to evaluate the integral. It's going to be 1x minus 2x to the 3rd over 3. Remember, we're going to add 1 to the exponent and divide by that number. And this is going to be from -1 all the way to 1. So we're going to have pi. I'm going to put square brackets. I'm going to put evaluate 1. It's going to be 1 minus 1 cubed times 2 minus 2 thirds. 1 to the 5th power is still 1 over 5. Whatever we get here, minus, and this is going to be -1. This is -1 cubed. It's going to be negative. Times that negative is going to become positive. And then here, This is going to be negative 1 to the 5th power. It's going to be negative 1 over 5. Okay, we need to simplify this. Okay, to simplify this, remember that we distribute the negative, and we have to have common denominators. You can also use your calculator, and this simplifies to pi times 16 over 15, or pi 16 over 15. As long as you have a pi, it can be multiplying in the front, or it can be in the numerator. Okay, so let's go to example number 3. Example number 3, right here. So we have that find the volume of a solid revolving on the region y equals the square root of 16 minus x squared, but now it's revolving on the y-axis. Okay, so I'm going to go to my function and graph it to my decimals. Okay, so here, this is how my graph looks like. And I click here on the keypad, on this key right here to get more options, and here's the square root. So in this case, we're rotating it this way. So let me graph this on my paper and show you what we're doing. I only put this one because this is what we're rotating on the y-axis. Rotating it this way. Rotating it to this side so that it creates kind of like a half a circle. Or half a sphere, because we're doing volume. So this is my radius, and it's going to be changing with respect to my function. But since it's rotating on the y-axis, we need to rewrite this function in terms of y. So that means that we gotta solve for y. So to solve for y, we're going to take the squared. So first, we need to solve for y. So to solve for y, we subtract 16. We multiply or divide by negative. What that's doing is just changing the signs of everything. To get rid of the squared, we square root it. And this is what we're going to do to the integral. The limits, it goes from 0 to 4. Remember, we're looking at the y now. We're looking at the y values. So we're doing the integral, don't forget your pi in the front, from 0 to 4 of the square root of negative y squared plus 16, and we square this. But now let's do y. Now it's in terms of y. The square root and the square cancel. So we have negative y squared plus 16y. Let's do the integral. We have our pi. I am so sorry, this is 4. This is a 4. So we have pi. Here we add 1, so it's negative y cubed. And then we add a y. And we're going to evaluate it from 0 to 4. 0 to 4. So we're going to plug in 4 for every y I see, minus, and then I'm going to plug in or substitute a 0. But this side, all of this side is just going to go to 0. So in reality, I just need to simplify the first part. All of this go to 0. Disappears. I don't care about it. I care just about the first part. After simplifying, we get that the answer would be pi times 128 over